Okay, so we are absolutely swimming in data every single day. I mean, think about it. But how do you make sense of it all? How do you find that one single number that kind of tells the story of a whole group of things? Well, that's this whole idea of what's typical, and we're about to unlock exactly how it works.
So let's start with something you've probably run into. You're at a shoe store, right? And it seems like they have a million of one size, but your size? Constantly sold out. Why is that? I promise you it's not just bad luck. It's actually data doing its job.
And this idea, it's literally everywhere. In sports, you don't really care about every single basket a player made all season. You want to know their average points per game, right? Same thing at school. A whole semester of hard work, quizzes, tests, homework, it all gets boiled down to a single grade. In every one of these cases, we're on the hunt for that one number to represent the big picture.
So yeah, that's our big challenge. How do we take all this messy, scattered information, shoe sales, basketball stats, test scores, and funnel it all down into one single, simple, meaningful number that actually represents the whole story?
All right, so here's our game plan for this explainer. First, we're going to figure out what typical even means. Then, we'll dive into our three main tools, the mean, the median, and the mode. And probably the most important part, we'll figure out when to use each one.
First up is the one you've definitely seen before. It's our most common tool, even if you know it by a different name. Let's talk about the mean.
The mean is what most of us just call the average, and it's the real workhorse of statistics. Its whole job is to find the perfect balancing point in our data. You know, that one central value where everything else seems to cluster around?
So let's see it in action with some student grades. It's super simple, really. You just add up all the scores, which gets us to 832. Then you divide by how many scores there are, in this case, 10. And boom, the mean is 83.2. So this one number tells us the typical student is getting a solid B. Seems straightforward, right? Well, there's a catch. The mean isn't always perfect.
And this right here points to the mean's biggest weakness. What if one student just had a terrible day, completely bombed the test, and got a 0? That one single score, what we call an outlier, would drag the whole class average way, way down. It would make it look like the typical student is doing much worse than they really are. See, the mean is really sensitive to those extreme scores. So to deal with those pesky outliers, we need a different kind of tool. And for that, we bring in the median. The median is specifically designed to find a center that can't be pushed around by a few crazy high or low numbers. The median is all about one thing: location. All you do is line up your numbers in order from the smallest to the largest, and you find the one that's physically smack dab in the middle. That's it. It's the true halfway point, and because of that, it completely ignores how wild the numbers at the ends might be. Okay, let's give it a shot. Here we've got a jumble of 9 different quiz scores. To find the median, the very first thing we have to do is bring some order to this chaos. There we go. That's the first and most crucial step. You have to arrange them in order from lowest to highest. Now we have a nice, clean lineup to work with. And now finding the median is just easy. We just look for the number in the dead center. Since there are 9 scores, the middle spot is the 5th one in line, which makes our median a 7. And get this, it wouldn't matter if that top score was a 10 or 100 or even a million. The middle number is still 7. That's what makes the median so tough and so reliable.
Okay, so we found the mathematical balance point with the mean and the true middle with the median. But what if we don't care about the center at all? What if what we really want to know is just what's most popular? For that, we need our third tool, the mode.
Hey, remember our shoe store from the beginning? The manager doesn't really care about the average shoe size in a mathematical sense. What they need to know is which size is flying off the shelves the most, so they can order a ton more of it. This isn't about balance, it's a question of popularity, of frequency. And that, my friends, is exactly what the mode is for. Honestly, the mode is the easiest one of these to get. It's just the value that shows up the most often. Think of it like a popularity contest. You can have one clear winner, you could have a tie between a few values, or if every single number is unique, you might have no mode at all. So, if we look back at our list of quiz scores, a quick scan tells us that the number 8 shows up twice, but every other number is only there once. Simple as that. The mode for this data is 8. Okay, let's hit pause for a second. For that exact same set of quiz scores, we found the median was 7, and now we see the mode is 8. And if we calculated the mean, we'd get yet another number. So
we have 3 different tools giving us 3 different answers for what's typical. How in the world do we know which one is the right one to use?
This is basically our decision-making cheat sheet. The rule of thumb goes like this. If your data is pretty clean, all nicely clustered together without any wild numbers, the mean is a fantastic choice. But the second you have extreme outliers, think about a list of employees' salaries that also includes the CEO's salary, you absolutely need the median. And when you're not looking for a mathematical center at all, but just the most popular choice, like the best-selling t-shirt color, the mode is your answer, hands down.
And that really is the most important thing to take away from all of this. There is no single best way to find what's typical. The right tool always depends on your data and, more importantly, on the question you're actually trying to answer. Are you looking for the balance point, the true middle, or just the most popular choice?
So, now we have a whole toolkit for finding the center of our data. But what happens when the data isn't clustered neatly in the middle at all? What if your numbers are all over the map? How do you measure not just the center, but how spread out everything is? Well, that sounds like a story for another explainer.